Okay, so let's start the recording. So this video actually covers the same things that we've been covering for the past few weeks, but in light of this one, okay, we're actually going to add in a human-machine interface to this particular program. Okay, so the item that you see here is actually just a uh, count up timer. Okay, so the count up device or functional block. Okay. Let's adjust this one to be negated, meaning to say kung if this is zero, this is if the conditions for CPU is zero when PV is not met yet, hindi pa siya count, the present count CV is not yet equal to PV, we're going to have a value of 1 here. When it's equal to PV already, this one becomes 0. So it will close down. We'll use the rising edge for this one, P, and then reset is being done with S2 in this case. Okay. So if we try to manipulate or to change or to add to this functional block, we would need to add specific set of conditions as alternatives to S1 and S2. Okay, so we're going to add additional control structures. Okay, for that reason, we'll need to add in two more additional connections for the left rung natin. Okay. So what we'll add in is actually quite simple. It's just additional Boolean functions or Boolean inputs that can be accessed. Okay. So when we say Boolean inputs that can be accessed, they are not part of the input. Okay. They are not IX because IX can only be read. Okay. It cannot be covered by the particular uh, set of alternative entry. Okay, you can't write to it. Okay, so in this case, we may need to add additional output coils instead. Okay, but we cannot use the existing output coils, which is associated with D8, D12, or D13. Okay, so in this case, we'll start with 4, and then we'll go to 5. So these are now virtual in coils. Okay, virtual coils. Okay. So when we go to this one, we just need to add in now a rising edge two. Okay, P1. Okay, I'm not using out. I'm using P. Okay, as a container connection. I'm connecting this one here. So you can have a count up if you either have S1 or P1. This is a virtual AND. Okay. On the other side, okay, we'll add in another item here. Okay. This one is P2, and just like the other one, we'll set it as negated. So meaning to say it activates if it's 0. Okay. Okay. So that this is how it looks like now. Okay. So we need to make sure that we have initial conditions set properly. 0 is the initial condition for S1. 1 is the initial condition for S2. Okay. The initial condition of, okay, I think this is incorrect. It's supposed to be false. True, false, false. Okay, that's 0 kasi. Okay. Okay. So now that we have all of these things, let's save the program again. Okay. And we can proceed to to have values listed. Okay. By the way, CV container also needs to be displayed on the Modbus. Okay. For this one, we need to use QW. Okay. 3. Okay. So this one is ano, container for present count. Okay. Okay. So with this done, let's save once more. Okay. And let's place the program into our Arduino. So save natin siya. Okay. Okay. There's an error. Okay. PLC code generator is being used by another. Hmm. I wonder who is using it. Or do I have two instances of this one open? It's odd because I just opened this computer app. Kakabot pa lang niya. Okay. Yeah. Okay. Let's see. First program. Let's try it again. Okay. This time it works properly. COM5 tayo. Okay. Make sure to check the Modbus RTU serial and to specify your specific slave address. Okay. Okay. So cancel since it's uploaded already. The program on my Arduino in front of me has already changed. Okay. So next, eh, killed it off. Okay. So again, device ID 10. Okay, coil status we have actually how many coils? 6 coils because we're including the virtual coils that we put into the consideration. So there we have that one, and we need to place in new input coils. We only have two at this point, S1 and S2. Minus ID 10. Suggest the margins. Okay. Connection. Eh, not yet. We need a holding register. How many? 5. No. Device ID 10. Okay, this is supposed to be 5. So for the holding register, what is my basis? So the basis should be the position of this W3. Okay. So 0 is the first one, which is what that one. This is 3. It should be holding register for 4. We'll see that one later when we try to modify this one, this item. The coil status, on the other hand, is also much the same thing. We won't have any values for 2, 3, and 4, but we'll have values for 1 and 6, 5 and 6. Okay. So let's connect to COM number 5 for this case. Okay. 9600. Let's wait for it to connect. Okay. As you can see, we have the common values associated here. Okay. And we have this response. Okay. So if I have a value fitted in number 2, okay. So I'm now looking at my board. And I'm wondering how come the other side is this value here. Okay. I think for some reason I mixed up the values. No, they're not mixed up. This is still false. Okay. That being said, if we raise this one to 1 and we update it, we should see The counter is actually counting up or down in this case. So our counter is supposed to be fitted in holding register 3. Okay. It's not one of the input registers because those are analog to digital control devices. Kasi naka-reset siya. I-on ko to. Update natin. I-off ko to. So it's permanently set to off position. Okay. That's a problem. Okay, for some reason it's not responding. Let me put in a reset. You see the timeout message because I fitted a reset to the whole system. Still not responding. Okay. So we have okay, have a problem here. Initial values are not being taken. So let's delete these two items. Oops, sorry. Instead, use the two. Okay, so this would be fully Modbus driven instead of switch in Modbus driven because I have a problem here with my hardware. For some reason, pin number 2 is held to 1. Okay, D2 is held to 1. So, not a very good start to things. Okay, so we'll upload the new program which only uses P1 and P2. So no need to change the values here because it should work. Okay. By changing 5 and 6 only, we should get a value across 404. So let's, you can see the counters going up. Okay, I think I know now. I'm looking at the incorrect thing earlier. This is an output, okay, and this is my input, okay. It's pretty obvious if you look at it here, okay. So I keep on forgetting that this is an output, okay. So that's 2, that's 3. When we reach 5, you should be able to see that this turns into 0 because now it's at the same value as the specific reference that we have, which is basically 5. Okay, there we go. So to reset, you just put this to the off position. You see that the current value is reset. So this is fully Modbus again. So let's remove those things and then save. And let's put it into the virtual environment. Okay. So take note here. I'm clicking on this one. Can't do anything because it's actually set to 0. Okay. So let's make this one as normal. 2. Okay. Or let's just remove the values. Oh, undo. Save. Disconnect this one and re-establish the program into the system. Okay, we're uploading the program. It's done now. Okay. So we've added in a rising edge and a signal. Okay. This has to go high for it to operate. Okay. So let's do a connection, COM5. So this is now the revised signal diagram. I'm using my fingers to connect to the 5-volt input and the 1, 2-volt output. You see? Okay. So I'm using now, okay. I keep catching the D3 as well. So it's creating some problems. Okay. As you can see, it works too. If I place my value here and click on the reset button, you see that 404 actually becomes equal to 0. Okay. So we have a functional program now. Okay. So this functional program can be now set into a specific HMI. For the HMI, we'll use Winlog Lite. Okay. Winlog Lite 3. Okay. Winlog Lite 3 is actually a commercial software. Okay. Uh, the company was really kind enough to to allow us to actually use it. Okay. Main. Where am I getting this one? Mukhang nakaano siya. Project manager. Okay. Now what you saw there is this one. Okay. So we need to do a couple of things. We need to make a new project first. Okay, new project, create new project. Let's call it as Counter HMI. Okay. So next, we need to set the channel. Channel 1 needs to use Modbus RTU. Okay. We need to use COM5 with the following parameters. Okay na yan. Okay. Devices. Okay. We need to add a new device. In channel 1, we'll add the device 10, which is our nano PLC. Okay. So the description is any description. It's a sensor, remote sensor 22, pwedeng ganun, remote sensor front door, remote sensor back door. You can actually assign this one with a more easier to follow naming convention. Okay. So next, we need to add in the tags. Okay. The tags that we used for this one, we actually used S1. Okay. S1. Let's place description. Okay. CU, physical. Okay. Since it's used for physical control. Okay. Channel 1, device 10. Okay. Now, this is where it becomes tricky. Okay. In the past, we've been using 1, 00, sorry. In this case, 1, 0, 0, 0, 1. We've been using that one. But in this case, the naming convention is a bit different. Okay. When we're using input coils or input status rather than output status, we need to use 2 DAO. And take note, the numbering starts from 0, not 1. Okay. So this one is actually 2, 0 siya. Tapos we always sample it and the sample frequency is every 1 second. Okay. So we'll add in a new channel. Okay. Copy, paste. Yes to all. Okay. So this case becomes 1 naman siya. Okay. So this is switch 1, this is switch 2. Okay. We have here an additional item. Okay. Out O 1. Output LED. Okay. 1, 10. Okay. So in this case, it's 1, 0. Okay. Because our previous value started with 1, uh, so 0, 0, 0, 0, 1. Okay. But that's base 1. This is base 0. Okay. So you have to do that one. Okay. Tapos we need to add in another 2 items with this. Okay. So in this case, P 1 and then 1. Okay. In this case, balik tayo dun sa Modbus. Nandito siya sa 5. 5 become converted to base 0 is 4. So 4 to. This is virtual CU pin. 1, 4. Okay. Tapos let's always sample every 1 second. Okay. Copy, paste, install. This is 5. Virtual reset pin. So virtual physical reset So now that we have it all sorted out, let's place in save. And let's move to the next one, the numerical side. Okay. We have only one number. The number is actually based on this value is in holding register 4, which is now 3 when we convert. Bawas lang kasi ng 1. Oh, sorry. So, in this case, balik na naman tayo dito. Gate ID QW4. Ilalagay natin sa kanya. The description is present count. The sampling is done with 1 device ID 10. And now, let's go into holding register 3 and then followed by 4. Okay. 3, 4. It is always sampled every 1 second. Okay. So, yun na siya. So, once done na tayo dito sa isang to, okay, we can move towards the actual template. Okay, new template, no name, virtual, and physical, counter. So the first thing that you need to do here is to add in all the gates. Okay. Go to your digital, select everything, and add them. To your numerical, select it and add it. So what does this action do? It tells that the program that this surface, this HMI, human machine interface, uses all of those numbers. Okay. Tapos ilagay natin siya ng title. Let's call this Counter HMI. Okay. You can sort out to make it a bit smaller rather than a very large HMI. Okay. Para ang tendency, nandun lang siya sa isang side ng screen mo. It's not cluttering anything. Okay. Counter HMI. Okay. So next, let's add in a LED para dun sa output natin. So the LED is humongous. Okay. Very large LED. Okay. LED conditions to turn it on or off. Let's add in the gate that we want is O, and the operator must be equal to 1 to turn it on. Okay. So yun na siya. Okay. So next, we need to add in a push button. And we need to add in another push button. Okay. Then we need to add in 2 more LEDs. Okay. The 2 LEDs are actually for the physical switches that we have. Okay. So in this case, we'll click on this one and we'll delete this entry and add in gate, which is S2, and say that if this is equal to 1, it should be lit. Okay. So this in turn needs to get deleted. Okay. And replaced by S1. If this is equal to 1, should be turned on. Okay. So as for the buttons, we have a button name somewhere here to label. Okay. Let's call it P1. And let's call this one P2. Okay. The function key of this one, we can set it to any of the function keys that we want, but we want the buttons to be able to manipulate a specific uh, okay, specific value. Okay. That value is P1. When the button is pressed, it should make P1 equal to 1. Okay. Or maybe this is incorrect. Dapat on click na lang. May default value rin kasi dapat to eh. I don't see any default value listed into this one. Edit. Equal to 1. Delete. On click, it should, okay, iba to. This one is for operation side niya. It's a weird part, pero you might as well capitalize on it. Or maybe this is the wrong button. Do we have another button? Ah, okay, switch. Sorry. It should be this one. Okay, P1 and P2. Okay, my bad. Okay. The on condition for this one is that we should be using gate P1 with the initial value of 1. Okay. Tapos meron tayong value rin here. Right click. Okay. This one is P2 naman siya. So when you put it to on, goes to 1. Yun ang ibig sabihin nun. Okay. Tapos you should have a response button on the other side so that you can see if really this switch is actually doing the desired job. Okay. So maglalagay tayo ng another LED na naman dun sa kabilang side. This one is for my inputs. Copy, paste. Okay, let's change the appearance to 82. Green siya. Para alam natin yun yung kabilang side. Ito yung pang physical switch. Ito yung pang virtual switch. We just need a feedback mechanism. Tapos we change this one. We delete this. And then we add in P2 operator equal to 1. Okay. We can do it this way. So this one, again, I'll delete this. I'll add an operator P1 equal to 1. Okay. So last but not the least is the numerical value. Okay. So we can just place in a label. Okay. That label can say specifically a value like current count. Okay. As you can see, hindi siya lumalabas lahat. To make sure na i-adjust mo siya. Tapos maglalagay ka dito, label ulit. But this time, we now call the gate number to occupy it. Yan na siya. Current count. Lakayan lang natin. Font. Yan. Malaki siya. Tapos, save natin. This is already our template. Okay. With all things set, close natin siya. Okay. Counter, run. Okay. We need now to take a look kung nakikita ba niya o hindi. Okay. Chances are this is not going to see it initially. Okay. As you can see, it's all full bar. Okay. Dito sa ano na to. Okay. What we need to do is we need to go to devices and we need to disable the device and reset the error. We then need to enable the device. Hopefully, this will fix the problem. You can see nag-okay na siya. Okay. So, pag tiningnan natin ulit yung status ng gates, this should all be green. Nakikita na niya. Okay. So, this item here took around 3 months to actually figure out. Been wrestling with this problem for quite a long time. Okay. Now na gumagana na siya, let's launch our values. Okay. Okay. So we're not seeing a change in the value count. Okay. Ano yung rason? Okay. The reason could be this one. Pero negated siya eh. This is being recorded again because somehow when the connection got cut, it was still recording and it was still showing that the screen was being shared. But when I reviewed the video, apparently the screen wasn't being shared anymore by 43 minutes and 43 seconds into the first recording. Okay. So that being said, I'll just cut it out from the original video and then place this as a additional item into the system so that you can see that the time difference jumped from somewhere much later in the past, around 5 something to 6:32. Okay. Now, I made some changes to the program. I've added an OR gate. Okay. Because the connection that we were using is a virtual and sometimes this causes problems, lalo na if one of your inputs is held to 0. It doesn't work properly kapag dating dun sa ano na yun. At the same time, let's make this one into negated eh. Okay. Okay lang naman na negated siya. Save, and then let's push it into the system. Okay. So no issues. Let's write it into the system and let's test it out once more. Status gates digital. They're all still running. Okay. So reset ko. Hmm. Naiwan nakabukas yung application unit ng project manager. Okay. Counter HMI run. Again, we run into the same problems that we had run into yesterday. Okay. Na hindi gumagana yung, yung digital natin. Okay. Template, and as such, hindi rin nag-enable to. You can see all of them are really errored. Okay. Devices. Disable ko, reset ko yung error. Enable ko. Should see it already. So this is a program which is very different already. Still, hindi pa rin natin nakikita yung gusto natin. Pero when I handle the physical pin and connect it, yan na, kikita nyo nagkiklik na siya. Okay. So again, this is not an issue with the HMI. This is an issue with the program. Dun sa OpenPNC editor yung issue natin. Not really with this one. But as you can see here, kapag ni-reset ko siya, physically I can see na nag-reset yung counter. And I can see also clearly kapag kumukonect siya. Okay. Dapat lang dito, kapag sinet mo to, there should be a reset happening when apparently there's none taking place here. Okay. Okay. So that does it for the very basic HMI counter that we have. As you can see, nagkakaroon siya ng error dun sa S1, S2 natin. So from this one, you can actually build very basic rudimentary HMIs. Pero instead of investing on an HMI platform na dedicated HMI lang, can actually make it a computer. Because HMIs are actually, when you look at it, they're actually computers as well. Computers that only use Modbus or Modbus TCP IP. Okay? So yan yung dun sa path natin for this one. Okay? So I'll stop recording now.